Hey everyone, so now let's start the second session of the webinar. Today we are focusing on the integration and processing of multiple source data into SuperMap iDesktopX. And here, this session will be divided into 4 parts. First, we will learn how to import data in different formats into SuperMap iDesktopX. And then in the second part, we will have a grasp on the concept of coordinate system, and then I will show you how to set coordinate systems for each of those data sets, or transform the coordinate systems of the data sets to that of the other one. And then in the third part, here we will learn how to create our own vector data set and also add some features into it. And also here, besides, you can, as it is necessary in some of our GIS projects, you will learn how to aggregate vector data sets together or aggregate raster data sets together. And finally, we will learn how to manipulate data, like how to convert polygons to lines or points to tags, and also how to transform raster data to vector data as well. Now let's get started. First is about how to what data can we import it into SuperMap iDesktopX and how to import them. So first of all, here is a quick introduction about the commonly used data sets in GIS. And there are 4 categories: vector, raster, image, and spreadsheet. So vector data is a much precise data. It can record the precise shape and location of features on the ground, and also it is quite useful when we need to know the exact topological structures of those features and have analysis based on topographic relationships. And raster data, on the other side, is mostly used to get the records of some continuous values on a surface, like the elevation of an area, that is to say DM data, for example, and also like the precipitation of an area or the temperature of a specific region. All of these can be represented as continuous raster data sets. And raster data sets in comparing to vector data sets, raster data sets have a more simple data structure. So it is easier. So when we want to do some spatial analysis for relatively larger area, maybe raster for some larger area, raster data is preferred. Raster data would be our first choice. And then it's image data. Image data is kind of similar to raster data, as both of these kind of data both kinds of these 2 data have recorded the exact value of the location in pixels. But in raster data, the pixel value is the exact. But in raster data, the pixel value is like the elevation or the amount of precipitation for the specific location of that pixel. Rather in image data sets, the value of the pixel usually represents like the intensity of the lights received reflected by the specific location. or if we're using the scanned data set, or if we use scanned image, that pixel values in those kind of data sets would represent like how the image, how the scan map are going to be visualized. And so image data sets are really used for our remote sensing images with multiple bands, or the scan maps, we used to digitize some old paper maps. And lastly is the spreadsheet. For those who are not experts in GIS, they usually prefer to have some records of those spatial information in the form of spreadsheet. But we can easily connect those attribute information to our spatial data sets like vector or raster, as long as we have the spatial information recorded, as long as we have like the coordinate values recorded in the spreadsheet, or we can attach those attribute tables to our vector data, as long as there is a common field between the spreadsheet data and the attribute table and the attribute field of the raster data set. So here we have listed some common formats for different kind of data sets. Like for vector data, our mostly used data formats should be shapefile. That is, it is made up by SHP file and DBF file together, and also we could use some of data created in CAD software. And so here we supported those files. We supported CAD files like DWG and DFX, DNG, and also we also supported other formats of vector data sets like KML, GeoJSON, etc. And for image data sets, we all know that there is a bunch of formats of image data set, and we supported almost all of them, like JPG, PNG, GIF, and image, and also TIFF and GeoTIFF. And then it's about our raster data set. Here you can import DM data and raw data or BIL data into SuperMap iDesktopX as well. And for spreadsheet, here there are 3 types of spreadsheet can be imported into our software. That is CSV and Excel spreadsheet and TXT file. And then before we switch to SuperMap iDesktopX and learn the operations to import data sets into it, here's some tips you need to remember. The first one is there must be a data source connected to your current workspace before you import any data into it. And here are 2 types, and here are 2 ways to import the data. The first one is going to the Start tab, and then here under the group of data processing, find data import, and under it, here are a bunch of icons that represents different types of data sets you can import into our software, and you can choose from them according to what kind of data you want to import. And the second method is to simply select the data source you have connected to the current workspace and right-click on it. Then select import data set. And by that way, you can import all the data set, all the types of data supported by SuperMap iDesktopX into this into this data source. And if you don't have any data source connected to your current workspace, and you directly navigate to start data processing, data import, and you will find that you can't say anything under data import because there's no data source now you can use for the import. And so now let's move to our first demo, that is to import multiple source data set into SuperMap iDesktopX. And here we all know in our actual GIS projects, we would use data sets from different sources collected by ourselves or provided by someone else, so that we could have a comprehensive information for the study area. And so for today's demo, our study area is the southernmost state of Malaysia. And to do that, and for the further GIS application, we need to import all the data we collected for this state into SuperMap iDesktopX. And here, so now we will have a quick introduction on on all the data we need to import. So the first one is the districts of Johor State, and also the roads of the state and attractions in the state. And all of these three kinds of data is collected as shape files. We need to import them first, and then we also have found a map for the state in the format of CAD file. We can import it. Besides, we also have scan map. We also have scan paper map of this area, and it is stored as an image. And if you are interested about the land cover of the area of the state, then we also provide you with the land cover data in raster formats. And finally, we have a spreadsheet record all the information about of airports in Johor State. And all of this data have shared to you in the materials for today's session, and you can find them based on their types. According to the name of the folder, according to those folder names. And so now I will show you those data. We have already shared. The data we are going to use for today's webinar, and that will be stored in the folder called 02. And inside it, we can say this is the organization of the data sets we are going to import it. The first one we need to import it is the shape file here. We can open this shape file folder first, and we can see inside it we have three shape files for attractions. This Johor is the districts for the state, and also the road for the same state. And so now we will go to SuperMap iDesktopX and import these three shape files first. And first, I will close the data source I opened before. And so now, as you can see, here under data sources, I don't have any data source. And so now, can I import any data sets into the workspace? If I right click on data source, we can see all the options. There's no options for import. And if we go to the tabs, we go to the Start tab and find the group for data processing. And under it, we can see that there is a button for data import, but it's gray and we cannot click on it. So that's what I said before. We need to have a data source connected to our data space, to our workspace, and then we can import data sets into it. And to do so, we will select data sources in here, the workspace manager on the left, and then right click here. I will guide you to create a new file data source. After right click, choose new file data source. And now here, you can find a location to save your own data source. And I will save it inside the folder called 02, and I will name it as the name of the state, and click save. And immediately you can see that under the workspace manager and under data sources, here is the data source we just created. But as it is a new data source, we don't have any data sets inside it. So our next step is to import the data source, import the data source, input our data sets into it. And so to do that, first we can try use the tools in the under the Start tab, and still we're going to find the group called data processing. And under it, you can see now we can click on data import, and all these buttons are organized according to the type of data the type of the data sets we are going to import it into our data. We're going to import, and here we will first import vector data, and under it we can directly choose the one for shapefile. And now here, I already navigated to where I have those shapefiles stored, and you can navigate to your folder here as well. And we can see that both the DBF file and the SHP file can be read here. And I would recommend you to import the SHP file, because that would import the features, both the features and the attribute tables of the records inside the shape file. If you choose to import DBF, you can only have the attribute table imported. And so here, first we will choose the SHP file for Johar attractions, and you can push Control button on your keyboard and then left click on the SHP file for the district and the road, and select the 3, and then click open. And here inside this interface, you can see on the left, it lists all the shape files are going to be imported. And now we have selected road, and on the right, we can put some parameters to set how these data sets are going to be imported, like which data source to store it. If you have multiple data sources connected to this workspace, then you can choose the one you want to use. And here we will use the one we just created. And then it's about, after imported, what's the name for this imported data set. And here I would like to name it as roads. And we can also change the name of the result data sets for the district, and also for the attractions. And now we have now we have all the settings down for our 3 data sets. and then simply click import. And now under the workspace manager, we can see here are three data sets inside Johar's data source, and we can double click on each of them so that we can see them in the map window. So you can see all the three data sets we imported. They are point data set, polygon data set, and a line data set. And there's no differences between them in the procedure of data in the import procedure. So now we can close all the windows, and we don't need to save them. And that's all you need to know about how to import shapefile into SuperMap iDesktopX. That is quite simple. And then let's going back to our slides. And here also we have some hints on how to create a new data source and import the data sets. If you miss anything of it, you can refer to the slides as well. And let me see if you have any questions about the import of shapefiles into SuperMap iDesktopX. If you right click on data source and it cannot open the interface to choose the location, then I would recommend you to close SuperMap iDesktopX and unzip the package again, and that would solve your problems. Well, yes, Windows 11 might cause some problems as well. So we would recommend you to use our software under the environment of Windows 10. Okay. Now let's continue, as you don't have questions for this part. So our next part is about how to import CAD file into SuperMap iDesktopX. And as we all know, CAD is a really powerful software, and you can create, and so the CAD file you created might contain a lot of information and also some styles. So when importing CAD into SuperMap iDesktopX, we have provided you with two options. That is to say, you can import CAD file into two formats. The first one is as the CAD file itself. So that would be, so if you choose this one, the CAD file you imported into SuperMap iDesktopX would be one data set with both with points, lines, and polygons and text inside it all together. And the original style saved in CAD file would be kept. But for that format, you cannot conduct any spatial analysis. And if you're only interested, like in the points in the CAD file or the polygons in the CAD file, and you don't want the information about the other features, then you can choose to import CAD file as simple data set. That would separate the data set. That would be imported as separated data sets of points, lines, polygons, and text. But the original style designed in CAD software will not be kept, and And for that, and for the format of simple data set, you can conduct some spatial analysis further. And so now let's move to SuperMap iDesktopX and see how to import CAD file. And here, I will first show you where we have the CAD file stored. It's inside the folder named as CAD, and inside it, you can say it's a DWG. It's a DWG file, and named as map for Johor in Malaysia. And so we will try to import it in another way. Here, inside the workspace manager, we will select our data source. We will select our data source and right-click on it. And then there's an option called Import Dataset. Click on it. And now, here's nothing, as we didn't select the files to be imported. And so on the top right, on the top left, here is a plus button. You can click on it and then navigate to where you want, where we stored the CAD file inside the CAD folder, and select that DWG file and click open. And now, do not click import immediately. We need to see the parameter settings for it. Here under the result data, we can see that here is a parameter called dataset type. And under it, it provides you with two options. As we said before, you can import it as simple datasets or as CAD file or in CAD formats. And here we will select CAD first. And for the results, for the name of the result data set, we can keep it as the original. And then you can click import. It might take a little while for import. And now we have it. You can see here, if we imported it in CAD format, there is only one data set added into our data source, and we can double click to open it. Here we can see, as we open it, there's only one layer for this work. There's only one layer for this map window, and the text, lines, points, and polygons are not separated. So that's format. So the CAD formats is usually used if you only want to see the data set itself, but you don't want to separate all the lines, or you don't want to separate all the lines or points. And so now, if we're only interested about the rivers in this data sets, and we only want to keep that, one, to do so, we can import the CAD file in another format. And still, we need to select to import data set and still add the same file. And here, all we need to change is the dataset type for this form, the dataset type for this import. And we will set it to simple dataset. And now just click import. And for this time, as our import results would be separated datasets, it takes a little longer And you can see under the data source, here we have added a lot of data sets, and they are named according to their names in the CAD file itself. Like here, we can like open that one for lake. And also add district to it. So here we can see now all the features inside it are saved into separated data sets according to what they are created in CAD software. And now they're stored in the vector format in SuperMap iDesktopX as data sets. So in the future, we can still doing some spatial analysis or processing application to this data sets if you wish. And also, here's a hint about how to import a CAD file in different formats into SuperMap iDesktopX. And so now our next step is to import images and raster data into our data source. Still, we can close all the windows for now. And still choose import data. Choose data import in your data source. And here first, we're going to import our image file. And this is a GIF file. We can click open. And here, we can see that we can also set the dataset type for our input result. It could be image or raster. And here, as we all know, for this import, we will treat it as an image. So we will keep the dataset type as image. And then we need to set the name for our result. And here we will set it as state map. And also here for the transformation parameters, here you can check create image premade, and that could enhance the efficiency. That could improve the browse efficiency for you of this image. And so simply click import. And now it has been imported, and we can right click to open it. And you can see here, this is a scan map of the state we're interested in. And you can use the wheel of your mouse to zoom in or zoom out. And then it's time for us to import our raster data sets. Still, here right click on the data source and choose import data set. And here we will navigate to the folder called raster. And here we provide you with two raster files, 01 and 02, and you can choose both of them and then click open. And similar to our import of the shape file, we can set the parameters for these two raster files separately. Like for 01 here, first we need to change the dataset type for it. we will change it to raster and give it a more meaningful name. For this data set, it is the land cover raster for our interested for the area we are interested. And so here we only set the parameters for the raster file 01. Then we can click on 02 and also set the parameters for it as well. And now click import. Here we can see both of the two rasters has been imported, and we can select both of them and then right click, choose add them to a new map. And this is how the land cover raster for the state we're interested in. And that's all we need to know about how to import datasets in different formats into SuperMap iDesktopX. If you have any questions for import different types of datasets, you can raise them in the chatting box. Well, if you are interested about like what other type of file formats if other type of formats of files are supported in SuperMap iDesktopX, here you can click on your data source and set import datasets, and here click and file, and then here under the file type, you can see here is a list for all the files, for all the independent files. You can import it into SuperMap. You can import into SuperMap iDesktopX, and also you can also import datasets into import your datasets into SuperMap iDesktop in the form of folders, like here on the right of this Add File button. If you click on it, here you can see this is all the files you can import into SuperMap iDesktopX that are stored in the folder format. And then we will talk about how to set the coordinate system for the datasets in the next part. Don't hurry. And okay, now. Oh, fine. Okay, there's one part I have missed. Also, we can import spreadsheet into SuperMap iDesktopX, and here quickly I will show you how to do that. Here first, we can see the spreadsheet. We want to import it. It is stored in the spreadsheet folder, and inside it, we can open this Excel spreadsheet. And here we can see this file is the record of the airports in the state, in the southmost state in Malaysia. And here are the names for it. And also we have the record for the latitude and longitude of each of these airports. And also we have a category field for it. And so as it has a record for the latitude and longitude, when we imported it into SuperMap iDesktopX, we can either store it as an attribute table or to directly convert it into a point vector. Now we need to close it first, and here I will show you how to import this data import this spreadsheet into our software. Here we can import it from our Start tab and find data processing, and under it, here we can find, here's a button for spreadsheet. Simply click on it and then navigate to the folder of spreadsheet and select this file and click open. And here we can see, as we only have one page for this spreadsheet, so here it directly reads it. If you have multiple sheets in the Excel Excel file, here you can choose which one is the one you want to import it. If this one is not the sheet you want to import, here you can delete it. But here we will keep it, and then we can see we can still set the name for the result data set. And here I will name it as airport. And here in the transformation parameters, we can see that here is an option for us about whether to import the first row as the field or not. Here we need to check it. And then underneath is a preview on how this spreadsheet would be imported. Here you can see all the information is corrected. If you see some word characters inside it, that means there is something wrong with the coding of this the coding of the file, and you can change it by click the coding about. There's something wrong with the coding about this Excel file, and you can change its code, and you can change the way it is coded in the way it is coded in Windows Excel first, and then imported it again. And here, as we said before, we have the information for longitude and latitude. So we can directly import it as a point data set. To do so, we need to check here, import spatial data. To check it, and then we need to specify which is a field for latitude and which is a field for longitude. Here we will choose the field of latitude, or longitude, and the field of latitude. And if we have another field of elevation information, we can also set it as well. Here, since we don't have it, then we can leave it as blank. Then click import. And now we can see that this is the data sets we imported. We can double click on it. You can see the spreadsheet is directly converted to these points. And if we right click on it to show its attribute tables, and here we can see all the information in the spreadsheet are also recorded in this attribute table. And in case if you don't want to save it as a point vector, you simply want it to be a attribute table, then when import it, here, just don't check this option for import spatial data and click import. Now we can see our new import is a attribute table. If we double click on it, we just open this attribute table, but we can use it further as we can connect attribute table to our shape files. Okay, now let's see if you have any questions. Okay, then let's continue. Well, so first is, so the second part is about the coordinate system. We usually use coordinates to define the position of the points or other geographic elements in the space. And here are three types of coordinate systems we can use. The first one is the plane coordinate system. This one do not have any reference to the global position. It's just take the interested area as a flat area and set a original point. Now it's not that commonly used for now. Now usually we are going to use geographic coordinate system or the projected coordinate systems. Geographic coordinate systems will use latitude and longitude as its coordinates, and usually that latitude and longitude, and usually it would have a ellipse point. It will have a ellipsoid design for it, and the most usual ellipse point we use now would be WGS 1984, and for the projected coordinate system, that is used when we want to treat our interested area as a flattened area, but also have some spatial relationships to the whole Earth, and in that way we would project our ellipsoid to a flattened area. And so there is a lot of projected coordinate systems based on how it was projected. And that's all the three types of coordinate systems we're going to use in GIS system. And for this webinar, we will mostly focus on the geographic coordinate system and projected coordinate system. And then when we have imported all the data into our software, our next step is not to directly conduct some processing or analysis to it. First, we need to examine if all of our data sets has the correct settings for their coordinate systems. There are three things we need to examine first. It's the coordinate values, coordinate system, and the coordinate consistency among the data sets. Coordinate values, that means you need to check if the coordinate values for your features in the data set is correct or not. And then check the coordinate systems. That is to say, if the coordinate values are recorded in degree formats, and then you use a projected coordinate system, then there is an inconsistency between them. So you need to fix them. And the coordinate system consistency among data sets means really we would prefer to set all the data sets for our project to one coordinate system. So it is easier for us to manage them and conduct spatial analysis to them. If the coordinate system for our data sets are different, then maybe we cannot apply some of the spatial analysis technologies to them. And so after we check all these three things, we would or those three things, we would get 4 results. The first one is the best one. Everything is correct, so we don't need to change any settings for our coordinate systems. And unfortunately, sometimes we would find the inconsistency between the values and the coordinate systems. As I said before, like the coordinate values are reported in the degree formats, and then you find that the data set itself used a projected coordinate system. Then that is to say, the coordinate systems for that data set could be wrong, and so we need to reset the coordinate system for this data sets. And also, we might need face sometimes we might face the cases where there's inconsistency among our data sets. And if we simply want to put our data sets together on a map and set their visualization styles that will not conduct further analysis or processing to those data sets, then it's okay to just use the dynamic projection, to simply use a dynamic projection when we are creating maps. And so when we're using dynamic projections, we won't change the coordinate system settings for our original data sets. And if we do want to conduct some spatial analysis to those data sets together, then the best choice is to transform the dataset the coordinate systems to use a uniform one coordinate systems for all the data sets. And the last one is maybe the most difficult situation. That is to say, the values for the the coordinate values for our data set are not correct, or we do say the values for the coordinate systems, but there's no information about which coordinate system the data set is used, and we can't find anyone to ask. And so in that case, the only thing we can do is the registration. And now I will guide you to fix all the problems related to coordinate systems. And here to do the demo about the coordinate systems, all the data we need to use is the data we just imported into SuperMap iDesktopX. And here we need to check if all the coordinate system and the coordinate values for them are correct. And if so, we will make all their coordinate systems consist with the coordinate systems of the data sets called districts. And so first, we're going to examine whether there are inconsistency between the coordinate systems and the values of the data sets. And to do so, generally we need to examine if the range of the coordinate system of the coordinate values consist with the type of the coordinate systems. That is to say, if the coordinate system of our data set is geographic coordinate system, then the range of its coordinate values should be in the range of the degrees. Like for its longitude, it should be between -180 to 180, and for the latitude, it should be from -90 to 90. And if the data sets use a projected coordinate system, then the unit for the coordinate system usually should be meters or miles or etc. And so the values for the coordinates should be larger numbers. And if we find some inconsistency between the coordinate systems and the values, then that means at least one of them is wrong. So we have to check which one is wrong, and usually it should be some missetting about the coordinate system itself. So we only need to reset the coordinate system for our data sets. And so now let's go back to SuperMap iDesktopX and just check the data sets we just imported. Here, we first need to check all the three vector files we imported at the first. And for this time, we would select all of them, all the three here, and then right click and add them to a new map. And once we did that, you can see that looks a little weird, especially when you here under the map window, check the scales of this map and to see the latitude number and the longitude number. And so now let's first select the data set of district and then right click on it. We can choose to see it to full extent. And here, once we select that, we can see that here, these yellow polygons is our district, and we have roads laid on it. We can make it visible or invisible. So that is to say, that is same to us that the coordinate system add values for these two data sets are the same, and they can perfectly overlay with each other. But for the attractions, that one should overlay on these in the areas of district, but it didn't. And if we see this one to the full extent, and once we see this one to full extent, we can see there's something wrong with the scale, and also the values for longitude and latitude is quite weird. And so to further examine it, we can select this attraction data sets and right click on it to check its browse its attributes. And then here, for most of you, you can only see these fields as by default, we will check hide system fields. And now if we uncheck it, now here we can see SMX and SMY is a field for the features. Okay, sorry guys. Let's see. Okay, you cannot see my screen. So let's quickly go back. Just now, I have added attractions, districts, and roads into one map window. And as we just checked before, we can see that here, if we see districts in full extent, we can see that the roads and districts perfectly overlay with each other. So that could indicate to us that there's nothing wrong with their coordinate systems or coordinate values. But for the layer of attractions, if we see this layer to the full extent, we can see that there indicates there's some under this map window. Here the steel indicates there's something wrong. And also we can see that the latitude value and longitude value are weirdly very large. And so we can open the attribute table for attractions, and then we can see and once you opened it, maybe you can only see these 5 fields, because usually we would by default we will check hide system fields, and if we uncheck it, we can see here the SMX and SMY is the fields for its coordinates, for the coordinates for the point vector data set. And now we can see the values for them seems very large, and that would indicate this data set should use the projected coordinate system. And if we select this data set and right click to choose properties, then we go to the tab for coordinate system. And now we can see it use the coordinate system with APSG code of 4326 and the datum of WGS 1984, and the unit of it is degree. That indicates the coordinate system set for this data set, and the value for this number and the value for it is is inconsistent with each other. So we need to reset the data set. So we need to reset the coordinate system for it. And wait a second. And so to reset it, first we need to close all the windows. And we don't need to save. We don't need to save it. Save the map window. And now here we can see that in the property window, here the first button is to reset its coordinate system. And also you can find the same button here under Start tab and go to the group of data processing. And here is a projection settings. If we click on it, it's the same as you click here. And now here we can see that now we're setting the coordinate system for attractions. And as we already know, there is an inconsistency between its coordinate values, and its coordinate systems. Usually, if you downloaded the data sets itself, you need to ask your data provider what should be the correct data set, the correct coordinate system for it. And here I will tell you the correct data set for it, correct coordinate system for it should be that with an EPS code, of 3857. And so now we can select the Mercator coordinate system and click apply. And now here we can see the coordinates for attractions, the coordinate systems for attractions has changed. And although it is still different from what of the districts and the roads, but now we can still select the three of them and right click, then add them into the same map. And here we can see here is a warning that is set the coordinate system for these three data sets are inconsistent, but we can open dynamic projections to put them in one map window. And now we can click yes. And after that, now as we zoom to the full extent of district, now here we can see those attraction points also perfectly overlaid with these two data sets, with districts and the roads. And it's okay if we only want to put them in this map window together, and we don't need to do further analysis or processing. And if we do want to use them for further processing, then we can also transform the coordinate system of attractions to that of the coordinate systems of districts. And to do that, we should close this map window first, and then still select attractions, and then we can either transform its coordinate systems under this property tabs. Here we can see on the right there is a button called for projection transformation, and also we can still go to Start tab, and under data processing, here we can find projection transformation, and here we need to choose dataset projection transformation. And now what we want to do is simply transform the coordinate system of attractions to the coordinate systems of districts. So now we don't even need to know exactly what coordinate systems district used. Here we can find that there's a button called copy coordinate system, and if we click it, now we can copy it here, select it to copy it from datasets and choose district. It automatically reads the coordinate systems of district and click OK. Now, if we click OK, it will directly transform the coordinate system of attractions to that of districts. And we can also give it a new name because we can save it as another data set. And if we want to transform the data sets of attractions to some other coordinate systems, here we can also use the first button, that is to reset coordinate systems, and under it we can search a coordinate system we want to use by its name or its APSG code, or on the left you can choose coordinate systems here according to its names as well. And now we will only use the coordinate systems of district and give attractions a new name as attractions 1, and click OK. Now here, if we select attractions 1 and also select district and roads, and then right click, still add them to the new map. Now here's no warning for the dynamic projections, and that is to say all the 3 data sets has the same coordinate systems, and we can use them for further processing and analysis. And here later you can also refer to the slides about a hint for how to set the coordinate systems. And here, as we encountered the inconsistency of coordinate systems among data sets, we have 2 solutions. If we only want to use them for simple visualization, just use dynamic projection. Or if we want further analysis, processing or analysis of them, then we can transform their projections. And here are hints on how to do that. And now let's take a break for 5 minutes. Then we will continue about how to correct the incorrect coordinate values, or to give a coordinate system to a data set without the information about its coordinate system. And now let me see if you have any questions about what we have learned before. If the data import is not active, that means you haven't connect a data source in your current workspace and create new data source there. Then you can input data sets into it. If you don't say SMX and SMY, here, let me show you again. Like if we open the attributes table for this one, now we can see on the bottom of this attribute table, there is an option for hide system fields. Now I unchecked it, so I can see this system fields. And if I check it, then there's fewer fields. Now let's continue. So in this project, we would say there are some data sets that has incorrect coordinate values, or we don't have any information about its coordinate systems, and we don't have anyone else to inquiry. And in that case, we have to find some reference data sets for the same area, and then through registration to assign a coordinate system to our data sets. And that would usually be used in the pre-processing of our image, of our satellite image, or for the files we get from photography grammetry. And also we often apply this method to our scan maps, like this one shown here. And so now in this demo, we're going to do the registration as well. And here is the general steps for registration in SuperMap iDesktopX. First, we need import the data set for registration, and also the reference data set for the registration, and then start a new registration and choose the registration method we need to use, and then pick control points. That is the key process that is the key step in registration. The next important step is to calculate the estimated error for the registration to see if it meets the registration criteria. If it meets the criteria, then we can do the registration and assign the coordinate system to our data sets. And now I'll show you how to do that in SuperMap iDesktopX. First, we will close all these windows, and we don't need to save any map of them. And then the data sets we need to register is the state map, the image data set we just imported. If we select it and to see its properties, here we can see under the coordinate systems, there's no information for this data set, because as we open it, it's clear, it's quite obvious that it is a scan map. And usually a scan map is just a scan picture, so there's no information about its coordinate system or the spatial information for it. But if we want to extract some spatial information from this scan map, then we need to assign a coordinate system for it. And to do so, we would conduct it through registration. And that tool can be found under Start. And then under Start, also under the group of data processing, here we can see that there is an option for new registration, and we can start a registration by our hands, create a registration by our hands, or if we have done some registration before for the same data set, then we can read and save the work as our registration file. So we can directly import that file. But now I will show you simply how to create a new registration. Click on new registration. So first step is to import the registration data. And that is the state map we just opened. Now there's no problem with it. Then we will click next. And here we need to add reference data. We could add simply one reference data, or we can add multiple of them. And here we would add the one called roads, because roads data sets, here we can see that there's a lot of intersections of the roads, and we can use them as our control points. So we will use roads data set as our reference. And if there's more reference data you want to use, you can still click this add button and choose the one you want to use as well. And here's one thing you need to notice: your reference data should has a correct coordinate system and a correct coordinate system values. And then click finish. And now we have opened a registration window. And once we open this registration window, we can see that among our tabs, there's a tab called Registrator. This is tab we can only see when we have a registration window. And under this tab, we can first add control points here in our registration map and our reference map, and edit them. And also we can choose the algorithms we are going to use for the registration. Here is the option for it. We can use linear and some other calculation algorithms. Here we will simply use linear. And here you need to notice that different algorithms has a requirement on the list numbers of the control points. Like for linear, we need to have at least 4 pairs of control points, and for polynomial, we need at least 7 pairs of control points. And it's similar to rectangular and offset. And now I will show you how to add those control points. Like we can see here, this intersection on the left should be the same intersection on the right. So this could be our first control point. And so now move our mouse to the window on the left and zoom in. Here we will add our first control point in the registration map in the center of this intersection. And now we have added one here. And then move our mouse to the reference map window and also zoom in. Here we can directly select this intersection point. And so this is the first pair of our control point. Then our work is to find similar control points of these obvious intersections, like here with this road all the way to the west, and this intersection here, and also select the intersection in the reference map. And we can see once we select this reference, this control points once we select these control points in the registration map and the reference map, under it, there is a record for each pair of our control points. It has its source coordinates, coordinates, and its target coordinates. And also, we can calculate the residuals for them. Usually, we will calculate it after we have enough pairs of the coordinate of these control points. And if you find like here, like I'm not satisfied with the point I added here, and I want to change it, and I want to change the position of it. Here, we can just go above and under the registration tab, simply click Pick Edit. And now we can put our mouse here and left click. We can move the position of this control point, and I'll put it here. And if I think, oh, I don't want this pair of the second pair of these control points, here under these tables, we can select the second pair and right click, just delete it. And now that pair of control points is deleted from this whole, from both the registration map and the reference map. And usually we would recommend you to add those control points, like, although the least requirement is 4 pairs, but we really recommend you to add around 20 pairs. And also, they should not be concentrated like just in this one area. It should be spread. It should be relatively equally spread in the whole region you want to register it. And we won't have enough time to select all the control points here during the webinar. And so I have prepared you with some control points I have already created for this registration. And to open them, here in the registration tab on the above, you can find here there is a button called Input. That is where we can input import the control points created before or created by others, and click on it. And here I have saved them in the 02. Under 02, go to the folder called registration. And here, this is the control point file I saved for you, and just click open. And once we click open, you can see that all the control points have added into our registration window. And if you have time, you can also try to add all of them by yourself. And once you have enough pairs of control points, here under operation, click calculate arrow. You have to calculate arrow and to see if it meets the criteria for registration. Then you can register. Then you can conduct the registration. And here we can see that the residuals is okay. Like in this case, it's okay if you have high requirements for the precision. You can add more control points or change the location of your control points. And now we can click registration. And here we can set how to save it. And we can accept all the default and click OK. And now we can see that a registered map, a registered image has been added into our data source. And if you created your own pairs of control points and you want to save them, you can click here, you can click export and save it. And then you can add it to this registration window as well. Now we can directly close it and to see and to open this map we just registered and click yes. And now you can see that it is registered. And as we select it on the right, we can see the properties of this map as well. You can see that now this map has an information for its coordinate system. And if we add the districts, into the same map window, you can see that it relatively, we can say that it's a perfect overlay of it. And that's all we need to know about registration. And so we could have a quick review. There's four ways to change or set the coordinate systems, like set the coordinate systems or use dynamic projection and transform the coordinate systems. Or finally, we can conduct registrations between those between data sets. It all depends on which problems we are going to tackle and what we are going to do with those data sets next. And let me have a quick review on your questions. Okay, not too much questions. Now, so I will just go on about how to create and edit data sets. And in GIST applications, sometimes after we added those scan map into our GIST system, and maybe we want to digitize some features on those scan maps. And to do so, we need to create our own data sets and edit them. And after that, maybe we also need to combine some data sets together. And so in demo 3, we will do all these tasks. What we first need to do is to create a new vector data set to digitize the place of interest features in the state map we just registered. And then we're going to learn the tools we use to combine vector data and to combine our raster data. And here I will directly and here, let's go to SuperMap iDesktopX. Here, we will make the districts invisible. And now we will have a further look of this scan map. And in its legend, we can see that there is some place of interest. And we want to digitize them, as we can put them as a recommendation for tourists visit the southmost states in Malaysia. And we can see now we can find some of these places of interest on this map. Now, as this map, as we already assigned a coordinate systems for this map, now we can digitize those features from this map. And to do so, first we need to create a new data set for digitizing. And to do that, here we can go under the Start tab, and here is a group called New Data Set, and we can select Point, or if you want to create data sets in other formats, you can select from here. Now click point, and here we will set its name as place of interest. And here we can set its coordinate systems, and we want to keep it the same as data sets of district. So here we can click more to open this coordinate system setting tab, and just here in the searching tab, simply open 4326 and select this coordinate system and click apply. And here also on the left, we can see that here is an add to map option. Now by default it's unadd, or we can add it to the current map here and then click OK. Now we can see here on our current map window, there is a new layer, but as there's no record of it, so although there's new layer, we can see no changes in the map window. And now we can zoom to where we have some point of interest, like here. And then in the map manager, find the layer of place of interest. And here, as I have introduced you in our first session, we can click on this editable button to make it as blue. Now that means this data set can be edited. And once we click it, then on the top, we can see that there is a tab called object operation. And here we can, as we want to join new objects, here on the object join, we can click on point, because this is a point, data set. So we can only add point to it. If we want to add line features or polygon features, we need to create new line data sets or new polygon data sets. And here we can click point. And now, as we move our mouse, we can see the coordinates of our current location of the mouse. And we put it to where we have the place of interest features and click. Now we have added one record here. And also there's another one. Let me see. Here there's another one. And there's a lot of place of interest features you can digitize. Here I want to show you how to digitize them. Once you complete your digitizing, simply click on this editable button again, editable icon again, make it green. Now you cannot add new features to it, but what we already added to it, you can see here, you still have this point. If I make this image invisible, it's much more clear. Now to save time, I will only digitize these 2 points, but you can digitize more if you have interest for them and in your own practice time. And now, as we have digitized those places of interest, maybe you have remembered that we also have a data set called attractions. That's also some places we can recommend it to our tourists, and maybe we can put them, and although we can put them in one map window, but maybe we can directly combine them together combine them together as a data set so that we can set their style of visualization, and also conduct further analysis or applications in the future. And to do so, there's two basic requirements for these two data sets. And let's go to slides to see them. Oops. Here, the first requirement is that we need to combine the vector data sets of the same types. That is to say, we can combine two vector points data sets together, or to combine two vector polygon data sets together. However, we cannot combine a vector point data set with a vector polygon data set, as their types are different. And the other requirement is that the data sets we're going to combine together should use the same coordinate system. That is, and how to make all the data sets have the same coordinate systems. I have guided you to do that before, and you can and so we won't talk more about it. Now let's simply combine the data sets together. To do that, we need to switch to data tab here. Here under data tab, there is a large group called data processing. And in data processing, here we can find that is a tool called append rows. That is to combine records of the same type together, and simply click on it. Okay, now we can open this window. And the target data sets is the original data sets we want to use. Like we want to keep our combined data set as the attraction ones. And source data sets is where we add the record, is where we stored the records we want to add it to attraction ones. And here, click this Add File button and select Place of Interest and click OK. And here you can find there is an option if we want to create new fields or not. If we click Create New Fields, then the fields that are different from the fields of place of interest will be created as new fields and added to the fields list of attractions. Or if you only want to keep the fields of attractions, just unclick these options and then click this Run button. And if we have opened this data, have opened attractions 1, just close it, click OK, then it can add records to it. Now, here we can see that the module extrusion has completed. And if we open the attributes of attraction 1, and here we can see that, scroll down the last 2 records, we can see that it has a position, but it didn't has the records for the other fields, as those records for attraction for the original records in attractions. That is the point we added. That is the point records we combined into attraction 1. And it's similar if you want to combine line data sets together or combine polygon data sets together. And then here for the raster data sets, we just import it here. We can see that we have land cover 1 and land cover 2, and we need to combine them together so that they can cover the whole region of Zhonghua state. And so to do that, still to combine them together, first we need to close all these map windows, and then go to Data tab. Still under the data processing, we can open all these tools we used for data processing and find those tools for raster data, and under it find slicing. This is the data. This is the one we're going to use to combine raster data sets together. And here it only read land cover 2 for us because we just select it in the workspace manager. And to add more data sets, simply click on the first icon and select land cover 2. And if you have more records, just add them here. And then here we can save the result as a new data set and give it a name as land cover without any number, and click OK. Now we have combined them together and simply click on it. Here we can see that we only have 1 layers here, and it covers the whole area of the state. That's all we need to know about how to combine vector data sets or combine raster data sets. And for the fourth part, it's quite simple. It's just about how to convert and transform the format of our data sets. For instance, sometimes we want to transform the fields in our vector data sets into text data sets so that we can use it as labels. Or we want to transform the polygon shape, the polygon vectors to line vectors, and all of this is called the conversion. And also sometimes maybe we want to convert vectors to rasters, or convert rasters or transform rasters to vectors. And here I will show you both of the ways of conversion and transformation. And going back here, so now I will simply open district, and if we browse its attribute table and hide the system fields, and now we can see that here is a field called LAA, and under it is the district name, is the name of the district. And so we can add them, and so we can transform these polygon data sets to text data sets, and the text information should be extracted from this field called LAA. And to do so, we need to go to Data tab, and still under the group of data processing, here is a group called conversion, and under it, we can see that here is a lot of tools, like you can convert points to line or line to points, and etc. And here we will convert fields to text, and you can try other tools if you wish. And here, the source data sets we're going to use is districts, and we need to choose which fields we're going to use to export, and that is one named LAA. And here we will name it as district name. And simply click run. Okay, we can directly go into slides to say how how the result should look like. Like here, once we convert it, it should be a data set look like this, and we can overlay them together, and all of this text should be falling into the polygon features associated with it. And then also our the last tool we're going to introduce to you is how to transform raster to vector. And to do that, we need to go to the tab called Spatial Analysis, and go to the group for raster analysis. And under it, we have the group for vector raster conversion. And here are tools to convert raster to vector. And we can set the parameters on the right according to the screenshot on the right. Here, let me see if it worked. Okay, there might be something wrong with the software. I'll restart it. Okay, I will restart SuperMap iDesktopX and show you how to use that tool in minutes. And now, let's see the application of our last tool. Okay, here. Before we have combined, let me see. Yeah, we have combined our two raster data sets together into one raster data set. Oh, well, that could be something wrong with this data set. Okay, here, I will combine them again. Okay, here we have combined them together. And in here, in the file I provided you under the raster folder, here is the index for this land cover data file. And we can see that there is 10 categories here. And now maybe we're really interested about these urban categories. And so we can extract these urban areas on this land cover data set and transform them into a vector data source. And to do so, we need to go to Spatial Analysis tab, and here find the group for raster analysis, and then find vector and raster conversion. Choose a file to like raster to vector. And now our source data set is this land cover data set, and we can set its null value and the tolerance. And here, as I said before, we're only interested in those urban areas. And here we can see the index for urban is 8. That means all the pixels with the value 8 is the urban area. And so we can convert these pixels with the specific values only. And we can set the value to 8. and the tolerance should be 0. And then we need to set for the result. And here we will set name to urban and click. Now it's completed. Here we can drag it into the map window. And here we can see it directly extracted those urban areas for this state, for this land cover map. So that's all we need to know for the session for this week. And now you can scan this QR code to complete the quiz for this week. There's still only 5 questions. And for this week, you don't have to submit, you don't have to upload any files or screenshots, just answer the questions. And also my colleagues will send the links for this week's quiz as well. Also, you still have 6 days to complete it. And our next session will start it on 3 p.m. in UTC time zone on April 27th. And so the quiz for this week is due on 2 p.m. on April 27th. And remember to do this to complete the quiz before our next session. And also you can go to our YouTube channel to see our playback for this webinar. The playback for this week's session will be available in 1 or 2 days. And that's all for today.